In this video, I'd like to look at a simple example where we can use the law of sines to deduce some information about a triangle that's not completely specified. What I'd like to do is I'd like to try to find the size of this angle, the angle that I've marked with a question mark, by using the information about this triangle that's given. Now this example has been chosen so that the calculations work out really nice and we can do everything by hand without needing a calculator. So if we want to try to deduce this angle, the law of sines is a nice choice because we have a pair, a side and angle, which are opposite one another, and we also know the side opposite to the angle that we're trying to find. So we have a calculation or information that involves two angles, so we can use the law of sines. And we have the correct sides, the opposite sides to each of the angles that are involved. So if we start out with the frame for the law of sines, we know that the ratio of the sine of the angle to the corresponding opposite side length is going to be equal for each pair of sides that we choose to use. So all we need to do to employ the law of sines to figure out the size of this angle is to plug the information that we know in the right way into this equation, and then to try to solve and figure out what the value of this angle must be. So I've chosen to measure the angles in radians here, so we'll go ahead and follow that convention as we go through. So we need to put an angle and its corresponding side in one side of the equation. So let's use the information that we know, the pair that we know, to fill in the left side of this equation. We can say that the sine of the angle pi over 3 divided by this length, 3, is going to be equal to the sine of the angle that we're trying to find. Let's give that a different symbol. Let's call it theta for the moment. So the sine of theta divided by its opposite side, which is 2 times the square root of 3. Okay. Once we've substituted all that information in, it just remains to solve for the value of theta. Because we have the sine of pi over 3 here, it might be helpful for us to draw out the table of the values of the sine function. So we'll go ahead and do that over here. So I'll measure my angles in radians. So 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2 radians, and hopefully that'll be enough for all the values that we need. And then I'm just going to put in the sines here. So we'll put sine of theta on this second row. And we know that when we're building this table, everything gets divided by 2. There's a denominator of 2 in each term, a square root in the numerator of each term. And then we start at the right value for either sine or cosine and then count up and down from there. So we know that the sine of 0 is 0. So we put 0 in, then 1, 2, 3, and 4. Okay? Alright, so from this table we can deduce that the value of the sine of theta when the angle is pi over 3 radians is going to be the square root of 3 over 2. So we can go ahead and substitute that in. And we'll have the square root of 3 over 2, which I'll just put in the denominator here. So 2 times 3 is going to be 6. That's going to be equal to sine of theta divided by 2 times the square root of 3. And now all we need to do to figure out the value of theta is to solve this equation. So we'll multiply both sides by 2 square root of 3. And that will bring me to 2 times the square root of 3 times the square root of 3 divided by 6 should be equal to the sine of theta. Okay? And let's simplify this. The square root of 3 multiplied by the square root of 3 is just 3. And 2 times that is going to be 2 times 3, which is 6. 6 over 6 is 1. So we get the equation 1 is equal to the sine of theta. If we want to solve that for theta, we need to take the inverse sine or the arc sine of both sides of this equation. So the answer, the angle that we're looking for, is the inverse sine of 1. We want to know what angle gives the sine function the value of 1. And we can figure that out by using this table in reverse. We look at the output of sine, we try to find that. We see we have the square root of 4 over 2 is equal to 1. The corresponding angle, the input to sine that produces 1 as output, is pi over 2. So from this calculation, the solution to this equation is that theta is equal to pi over 2, which means that this triangle is actually a 30, 60, 90 triangle. It's one of the special triangles that we're familiar with. Okay, so pi over 2 radians is 90 degrees. So even though I haven't quite drawn it to scale, it turns out that this is a version of a 30, 60, 90 triangle. Okay?